We are about to listen to the next speaker, who is engineering manager and iOS engineer at TopTal, and he came from Warsaw. What is also interesting, he's one of the organizers of Mobile Warsaw community, and he is an enthusiast of TDD. And his talk is about testing and why tests are indispensable development tool, and how to write good tests in Swift. Listen to inspiring journey of Paweł Dudek.
One, two. Okay, perfect. So my name is Paweł, and I'm here today to talk with you about writing mocks in Swift. Before we get to that, some words about me. I'm the engineering manager at this company, TopTal. I've been building iOS application and macOS applications for past 13 years. And at TopTal, apart from making sure the team is happy and runs efficiently, I also do iOS coding to make sure I stay up to date with the latest and greatest developments on our platforms. And I happen to be a father of 3, and I had really hard time explaining to my kids, thank you, a really hard time explaining to my kid, what the hell is it that I'm doing here? So what I'd like you to do is to give a wave to my kid while I take a picture of myself with you in the background. Hopefully, let's switch slides for slightly darker background. So can you do this for me? Yes, okay. One more. Hello. We'll see if that did not move or not. Cool. But that's enough about me. Let's talk about writing mocks in Swift. And for starters, I want to establish what kind of mocks we'll be talking about. And we'll be talking about the kind of mocks that record all the function calls made on them. And then afterwards, you can verify whether a certain function was called with some specific arguments. This is probably by far the most popular type of mock that you have in iOS land, mostly because it was popularized by OC Mockito and OC Mock a couple of years ago, back in good old Objective-C days. But technically, this is not a mock. The right term for this is a spy, but since everyone here just got used to calling these mocks, we'll stick to that throughout this presentation. And why would you want to mock? Well, most importantly, we use mocks to isolate a small piece of code that we have within our system. We isolate the small piece of code so that we can focus just on testing that part, so that if something fails, we know it's only specifically this small piece of code, not some other element in the system. This also makes it easier for you as a programmer to reason about how that specific function or piece of code behaves. Second, we use mocks to, well, verify whether certain things were called with specific arguments. And last but not least, we can use mocks to control the flow within our test by changing return values or the state of the mock that we have. And how do we do that? We do that using seams. A seam is a place in your code that allows you to modify the behavior without modifying the code itself. Sounds slightly tricky, but let's take a look at an example. Here, we have a simple type called release type service, whose sole purpose is to determine whether the app is running as a production or debug build. As you can see, it uses bundle main bundle identifier to determine that. And where's our seam? Well, it's exactly here. But we can't really change this because this is a singleton and we don't really have control over that. So we're going to use Swift's all-time favorite trick, and we'll do protocol-oriented programming and create a simple bundle ID provider protocol, which has only a single variable bundle identifier. Since the signature for this variable matches the signature from bundle type, we can just make an extension and not have to write any additional code. Then we inject that into our release type service. And now in our SIEM, we have the control over how the code executes from the test, because now we can create a simple mock, inject it into our release type service, and then change the values for our test to test for both the production and debug bundle identifier cases, as well as for any other case. And yes, this is missing default case on purpose because, well, that's not really necessary for this talk. And theoretically, this could be the end because, hey, we just found a way to create a mock and inject it into our code, so ta-da. But life is not that simple because we also have functions. And those functions can have arguments. The functions can return values, or they might even throw. And when I switched to Objective-C, from Objective-C to Swift a couple of years ago, I painfully realized that the tooling for creating mocks is essentially non-existent. This was back in 2016. Swift was pretty young, and there was no really good tool that could help me out with this. And today, I want to take you on a journey through the land of Swift mocks, where we go through a pretty bad solution for creating mocks in our code base to something that I think is truly amazing and is very close to what we had back in Objective-C and makes creating mocks and thus writing tests a seamless experience. And I'm pretty sure you all started your journey at the exact same place, which is where we'll start today, and that is writing mocks by hand. And now let's explore how we can write a mock for a very simple type, and then we'll keep on improving it until we arrive at something much, much better. So here we have a fairly simple type, foo protocol with a single bar function. And a very naive implementation of a mock could look like this, where we essentially just have a Boolean flag that we flip inside of our mocked function, the bar function. And then we make a simple assertion and verify whether it was flipped. But what if I want to know that the function was called 2 times, 3, 5, or maybe 42 times? Like, this doesn't cut it. But we can easily fix this by swapping the Boolean flag for an integer, which we increment in the function call. Quite nice, but, well, it still doesn't cut it for arguments. What if we have a function that has arguments? Well, in this case, what we could do is we could create an array of tuples, and we would shove down all the arguments onto that array. Now, technically, we don't really need the counter anymore because that information we can infer from the array of tuples that we have. So let's get rid of it. And now we kind of have the ability to both verify whether that function was called, how many times, and to compare the arguments. But how do we compare the arguments here? I mean, technically, we could just grab a tuple from the array at given index, and then we can unpack it and grab the actual values from it and then compare it with some other values. But that's not really readable. That doesn't necessarily easily convey the message. What is the expectation here? Going back to what Krzysiek said, this is kind of about developer experience. It doesn't make it easy for other people to understand what you're trying to test. It also makes it harder for you to express yourself in the test. What is that you're trying to verify here? Back in Objective-C with OC Mockito, we had this amazing approach where you could just say, mock this type, and then when you try to verify, you use the exact same function signature. And this was possible because OC Mockito underneath used Objective-C dynamic runtime to dynamically create new types and register them within the runtime and create types of it, which is freaking amazing, but also it's a shotgun that can shoot off your leg. So not technically recommend, but anyway, we don't have this in Swift, this kind of dynamism. So we need to find a different way. And when I kept on writing and repeating the same pattern over and over again, I kind of realized one thing. Each time when we create a mock type with some function with arguments, we keep on repeating the same pattern. Here we have an array of tuples, and onto that array we shove down arguments. And the array of tuples, it uniquely identifies a single function. So we kind of have function identifier. And we also have the arguments. This kind of resembles a similar type from Objective-C, which is called NS invocation. Not sure if who here knows what NS invocation is. Okay, not a lot. I mean, that's kind of expected. It's kind of obscure. Well, for the people who know what it is, yes, it also has a target on which the selector along with arguments will be invoked, but that's a side note. It's kind of similar what we have here. So technically, we could represent the stored arguments as some form of invocation. So let's see how we can improve our code using this pattern. And we'll start off by creating a simple structure that will just contain the identifier and the arguments. Now, the arguments are of optional any because we want to be able to throw down anything onto that array. And they're optional themselves because, well, we also want to denote the case where given function has no identifier, no arguments. Then we'll create a simple storage type that will essentially just hold all the invocations that we have just created. And then, in our actual usage of the mock, we'll throw the recorded invocations into the storage. And this was the stage one of my journey, where I kind of created a foundation for what was yet to come. Because now we have this a unified approach to storing all the invocations, meaning we can build additional functions on top of this storage. When we go back to the example with Objective-C, we also had matchers there. Not sure if you noticed, but there was a matcher that essentially said whether the string starts with some text. And we're kind of missing this in this solution. So let's now talk about matching arguments. And technically, what we want to have is to be able to say, given this array of arguments and this array of some expectations about the arguments, I want to determine whether they are true or not. Now, obviously, this is pseudocode and won't compile, but it's kind of an example of what we would like to have. So let's explore how we could do this. And the key to unlocking a pretty great solution here lies in the optional any type. Or actually, lack of type, because we use this to completely escape Swift's type system. And since we escape it, we now gain the ability to create a variety of different rules for our types. And we will create these rules using a very simple matcher protocol. This is all that you need for creating such a matcher. And it takes an optional any argument, because that is how we store our arguments. And then it spits out information whether, yes, this matches, and no, this does not match. And even though the interface is super simple, it actually allows us to create a lot of pretty nice interactions. And now let's explore how we can use this protocol to write a simple equal to matcher. Our equal to matcher is a generic type that takes in an object of T type that has to be equatable. Now, it's a generic type because in the match function, we want to be able to cast the other argument, the actual argument that we got from invocation, to that specific type. Now, if the type matches, then we can make a comparison because the type system says, yes, this is the same type. And also, obviously, there is a check if both the arguments and the value we expect to have are nils. And you can build a lot of other matchers using this pattern. In the code base that I work on, we have multiple others like identical to, instance of, a negate matcher, capture argument matcher, any matcher, and my all-time favorite, which was, I think, written by Karol over here, that allows us to simulate closure callbacks, which made working with closures much, much, much simpler. And how the usage looks like? Well, in a hypothetical scenario, first we can declare the array of the matchers. Then we grab the arguments from the storage somehow. We'll talk about that in a second. And then we, in a quite naive way, just iterate over the pairs and verify whether each argument matches its respective matcher. Now, obviously, this doesn't test for any edge cases like whether the arguments have the same count as the matchers, but for the sake of this example, this should be enough. And how can we fit all of this together? Because now what we have is, on one hand, the foundation with the storage itself, where we store all the invocations. We also have the matcher functions that allow us to compare arguments. But we need to kind of fit all of this together to get a much nicer approach to creating mocks. And we'll do that by introducing the most important type in this entire presentation, which is obviously called mock. And the mock type has two requirements. It has to be a class type, because otherwise we would die in the mutating function hell. And the other requirement is for the mock to have a storage variable. And this is actually it. And we're going to use one of Swift's coolest features as a language, which is the ability to extend protocols. Now, given we have this foundation in storage, we can write reusable functions on the mock protocol that will be available to any mock type that you have that conforms to this specific protocol, as long as it's a class and has the storage variable. So let's take a look how that looks like. First, we'll create a kind of syntax sugar function to not have to always write storage.record invocation. We'll just be able to write directly on the mock record invocation. And then we'll create another important function, which is the verify invocation with arguments function. And in this function, what we'll do is first, we'll grab all the invocations that match given identifier. So we want to verify whether, say, we want to ensure that we're verifying invocations only for a specific function call. Then we use a match function to check if there is a invocation whose arguments match. Now, I didn't include the match function here because it was pretty long and I was not sure if it will fit and be visible to those folks at the end there. Hey there. And basically what it essentially does, it does the same zip thing we saw a couple of slides ago, and it also checks for the edge cases that we talked about, which is whether both arrays have the same count or maybe whether both arrays are nil. And if we didn't get a candidate, we obviously failed the test because we wanted to make sure that, yes, there was an invocation that matches, there was no invocation, so we just failed the test. How do we use it? Well, now we can extend the mock type that we have here. And in it, we can write a verify bar function. Now, what's cool about that function is that its signature is very close to the original signature that we had in the type that we're mocking. So when we're actually using it, we're calling storage mock argument foo verify bar equal to identical to. And I mean, this is great. This is the moment where I thought it's starting to look nice. I mean, instead of some detached verifications on some objects that are taken outside of a array, we now explicitly are able to say what we are verifying here. And that was the moment when MIMUS was born. MIMUS is a mocking framework that I built along with Paweł Kozielecki a couple of years ago, and that I kept on using in every project that I joined since then. And what's really great about MIMUS is that it allows you to share all the matcher logic between all your test suits. So given now that we have this reusable matcher logic, you can write any matcher that comes to your mind that might be very specific to your use case, and you can reuse it across your test suite. And it's also a unified framework for creating mocks. So you actually get to have the exact same structure, meaning it's going to be easier for you to create the mocks and for any on your team to understand why this mock is written like this. This is pretty cool, but there's also one super ugly thing about this. And I mean, it's still a lot of manual work. We kind of went from having an unstructured, manually written solution to a structured, manually written solution, but it still has to be written manually. Though there is one thing that we all programmers just love doing, and kind of like Krzysiek said, and it's automation. We love to automate things. So when I reached this point, I thought, hey, surely there's gotta be a way to automate this. I mean, let's look at the code again. It's, again, repeating the exact same pattern that we have. We declare the storage. Then we have the mock function, where we record the values into the storage. And then we have a verify function that verifies whether the thing was called or not with the right arguments. It's the exact same pattern we'll keep on repeating over and over again. It's a lot of boilerplate that you also have to write. But then I learned that Krzysiek built this tool. And this is the moment where I kind of wanted to say what SOURCERY is, but I'm pretty sure everyone here was on the first talk, so I'll just quickly show excerpt from their site saying what exactly is, and I'll just go ahead and assume that everyone here knows what SOURCERY is. So fast forward through this slide. And how can you integrate the MIMUS with SOURCERY? Now, I won't be going into details how you can actually integrate SOURCERY in your project, because frankly, that's a topic for a separate talk. Also, SOURCERY has amazing documentation on how you can integrate it in your project, and I'm pretty sure everyone here is capable of doing that. So let's only explore how would the mocks created with MIMUS and SOURCERY look like. And let's start by what do you actually need to do to have a mock generated for a protocol type. That's it. You only have to annotate it as a mockable type in SOURCERY. Now, this is reusing existing annotation from SOURCERY, because I believe that if you don't, for some reason, like the way MIMUS generates code, you can just switch to a different stencil, and then you will not have to change your production code or comments and annotations on your production code. And how would a mock look like that would be generated using MIMUS and SOURCERY stencil? It looks like this. We again have our storage. We have our bar function with the two arguments. In the bar function, now you can notice that the argument is actually much more unique, because it's now using the actual function signature. And this is a great improvement. What I really hated about MIMUS initially is that because you had to write all the function identifiers by yourself, they were pretty error prone. It was easy for you to make a typo somewhere, or in that case, you could maybe have a test that should fail, but it does not fail. Or maybe you had a test that shouldn't fail, but it actually fails. And that's just bad developer experience, plus that can also lead to production bugs. But now, since the identifier is uniquely generated by SOURCERY, there is no room for any kind of error. And then the second part, which is, well, my yeah, that's the part with the storage. And then the second part, the instance verifier, which is probably my favorite part about how the stencil for MIMUS ended up looking. So this is just syntax sugar that I added because I really, really wanted to be able to have the exact same function signature we're making verification calls. The verify bar function didn't really look nice. So what this instance verifier does, it allows us to create the same function signature because it's the same type. It's a different type within our original mock type. And we pass the original mock in the initializer. The initializer is hidden here for the sake of clarity of this slide. And then inside the verification function, we just call the verify invocation on the mock that was passed in. And the usage, it looks like this. We create our mock, generated mock argument foo, then we do something within our code, and we call mock verify bar argument 1, argument 2. And this is great. This looks almost identical as what we had back in Objective-C and is super readable, meaning it's going to be easy for you to write the assertions and it's going to be easy for other people to understand what is being asserted here. And I just felt kind of in love at that moment because I found the perfect solution for my problem. And it allowed me to kind of not have to think about creating mocks anymore because they were all auto-generated. Now at TopTal, we use this tool extensively, and I think we have 25 to 30,000 lines of code generated just for mocks using this tool. And it allowed us to move faster with writing more tests at the same time. And the mocks, they're not error prone. They're always automatically generated, so you don't have to worry that you'll make a typo somewhere or that you might misconfigure your mock somehow. Now, the verify function is also slightly more complex. I kind of cut it for the sake of clarity on the last slide, but the actual implementation, this is taken directly from SOURCERY, from MIMUS. Rest of the slides that you saw were rather simplified code for the simplicity of the presentation, but this is actually what we have in generated code. So the verify function, it not only allows us to have the exact same signature, but it also allows us to pass a couple of arguments into it. Now, obviously, we pass the file and line so that we get a nice failure in case the test fails. But we also pass verification mode, which is a nice trick of being able to say that maybe we expect that the given function will never be called with such arguments. Or maybe we expect it to be called exactly 42 times, or maybe at most 1 time, or at least 2 times. And this is something you can actually already do with the stencil. And the stencil is also already available on the MIMUS website, so you can just add it to your pods. It's also available via Swift Package Manager, and you can start using it today. And how this looks like? Well, again, we create our mock. We do something in our system, and then we say mock verify mode at least once. And then we call the right function identifier, which is bar argument 1, argument 2, along with the matchers that we have. And here I'm using a different matcher, the any matcher, which essentially means I don't care about this argument at all. And MIMUS, apart from the stencil, apart from verifying whether functions were called, it also supports variables. It also supports functions that have return values and functions that throw errors. There is a footnote there because there is a much more advanced feature like this in the works, but it's not fully completed and currently only works for mock for types that conform, for arguments that conform to either equatable protocol or that are class types. If you have a different type, there is not ideal escape hatch, but you can try this out with annotating the function with advanced return annotation, and then you can actually say that I want to return value X for given arguments, which is much nicer than just, well, always returning the same thing. And that's all I had for you today. Now, I really strongly encourage everyone here to generate your mocks, because that makes everyone's lives on your team much easier. And you won't have to, well, waste time having to write them on your own. Now, I know MIMUS might not work for everyone here. I hope it works for someone at least, but I do accept it might not work for anyone here. In that case, there is a couple of other tools that you can check out as well that also help with creating and or generating mocks. There might be more. I don't know. These are the ones that I know of. And yeah, here is a couple of useful links. First link, my shameless plug with the repository where I keep all the interesting stuff about test-driven development. Go check it out. There is actually also a link there to a website by TestDouble. Who knows what TestDouble is, by the way? I see 3 people, 4. Okay, that is not a lot. And I also realized the question might have been very mischievous because TestDouble is also a company, but I'm assuming you thought about the mock type. But there is a link to wiki by TestDouble, the company, on testing, and it's an extensive knowledge about how tests looks like and what nomenclature you can use within, well, the testing community. And I strongly encourage you to look at it if you find it useful. Now, obviously, another shameless plug, link to MIMUS and slides for this presentation. And this is now truly the end. Thank you very much. And I guess we have some time for QA. Yes.
Yes, we have 6 minutes. Hands up if you have any question.
I guess lunch is more important than questions. Don't worry, I understand.
Okay, so in this case, thank you, Paweł, for sharing your thoughts.
It's been a pleasure. Thank you.